Okay, this is the review for Unit 16. Okay, on the first ones, all they want you to do to convert is to convert them. So that's the whole the base stays the base and the other switch place. So 3 is your base here, and a log always equals the exponent. So for this one, you would just have 3 to the power of a equals b. Now on this one, you're starting with an exponent, so you want to switch it to a log. So this is your base. So here I would have log base 5 of 20 equals x minus 8. Alright, and this skill is really important for solving, so we'll eventually get back to that when we solve. Alright, on these you're expanding. So, for instance, on this one, if I'm expanding it, I'm going to take care of this x first, and I know it has an exponent of 2. So 2 log base 4 of x, I'm multiplying, so I have to add, plus log base 4 of y. Alright, on the next one here, I'm dividing, so I know eventually I'm going to have a subtraction sign. So I have the 3 there. So I have log base 2 of 3 plus log base 2 of x. Now I'm going to take care of the dividing, so minus 5 log base 2 of y. Alright, on this one here, I'm doing a cube root. There's a couple different ways to do this, so I'm going to take care of the cube root first, and I'm going to put that in parentheses. So here I'm going to have 1/3 log of, then I need to have a 2 in front of that, and then a plus log b plus 6 log c. Okay, on these down here I'm condensing, so this is where they're going to get smaller. So I can tell I'm dealing with log base 3. So here I'm just going to write it one time, so log base 3. The 8 will be on top. I'm subtracting here, so that's going to be on the bottom. And then this is a positive, so it's going to be on the top. Alright, on this one down here, I have a half, so I'm actually doing a square root. So I'm going to do log, square root, and then I'm adding in here, which actually means I'm multiplying, so it's going to look like that. Okay, on these here, you are solving them. So the main thing here is you really want to try to get that base and that exponent by themselves. So once you get that base and that exponent by themselves, that's when you have to convert it. So for instance, on 13, I'm going to add that 3 over. That gives me 5 to the power of 3x equals 25. Alright, there's a couple different ways to do this one. I could do this one by hand, or but I'm going to switch it to a log. So that's my base. So I'm going to have log base 5 of 25 equals 3x, and then I'm going to divide by 3. So x equals log base 5 of 25 over 3. Now this one could actually be taken a little bit further because I can find a good value for that. So 5 to what power gives me 25? Well, that's 2. So 2 over 3. So x would equal 2/3. Okay, so for instance on this one, I got to get that base and exponent by itself, so I'm going to multiply by 4. Multiply by 4. That gives me 2 to the power of x equals 16. Now, I could change that to log base 2 of 16 equals x, and then I could just get an answer from there. Another thing I could do is I could do 2 to the power of x equals 2 to the power of 4, because 2 to the power of 4 is the same thing as 16. And if I do it that way, I can just cross out the bases, and I know that x equals 4. Alright, on these here, I'm trying to get the log base something by itself, for instance. So I'm trying to get this part by itself, and once it's by itself, then I can change it into exponential. So on this one, what I'm going to have is, I'm going to get rid of that 1/2, so I'm going to multiply by 2, then multiply by 2. That gives me log base 2 of x minus 5 equals 6. And that gives you 2 to the power of 6 equals x minus 5. Then I'm going to do plus 5 plus 5. Alright, 2 to the power of 6 is 64, plus 5 is 69. So again, you're just trying to get that log base something by itself, and then once it's by itself, then you can convert it and solve. All right, on the back side, okay, so on number 22, what you'd want to do on this one is you would want to get the log base something by itself, and it is, so that's all ready to go. All right, and then I'm going to convert it. So 2 to the power of 3 equals x, the square root of x minus 1. Okay, that gives me 8 equals the square root of x minus 1. Now I'm going to square this to get rid of it. So that gives me 64 equals x minus 1. Then I'm going to add 1, and x equals 65. Okay, I'm going to do on 24. Again, I have to get the log base something by itself, so this is by itself. So what I'm going to do is I'm going to do x to the power of negative 3 is equals 64 of 125. Now, you have to know that this flips. When you have a negative exponent, it's going to flip. I also know I'm doing the cube root, so I kind of have to do a cube root here to get rid of it. So that gives me x equals 5 over 4. The reason I flipped it is, again, because of that negative exponent. All right, on this one here, I'm going to get the log base something by itself, and it's by itself. So I'm going to put a 10 here. So 10 to the power of 2 equals x squared minus 3x plus 82. So 100 equals x squared minus 3x plus 82. All right, I have to make it equal 0. So that gives me x squared minus 3x minus 18 equals 0. And then if I factor that, get that. And so x equals 6 and x equals negative 3. All right, if I put in the 6, so if I substitute in the 6 here, I get 36 minus 18 plus 82. And this will give me a good number here. So this is definitely an answer. If I put in the negative 3, that gives me 9 minus 3. And this will also give me a positive answer. And so both of these are right. If I were to have substituted one of these numbers in here and gotten a negative, though, that would have been my extraneous. All right, so the next one here is okay, so the next one here they want you to solve, but you're going to have to do some condensing first. So if I do my condensing, I have log base 3 of x times x minus 2 equals log base 3 of x plus 10. Now, because the logs are the same on both sides, I can cancel them out. And then I'm going to actually just do that. So that's x squared minus 2x equals x plus 10. Then I'm going to subtract it, and then I'm going to subtract it. So that gives me x squared minus 3x minus 10 equals 0. And if I factor that, I get x minus 5 and x plus 2. So x equals 5 and x equals negative 2. All right, this will be my extraneous solution, because if I put in a negative 2 here, you can't have a negative there, so you can never have negatives here once you substitute the answer in. So this is my extraneous, and this is my valid. This is my valid solution. Okay, on the x-intercept one down here, remember the x-intercept is when y equals 0. So you're going to have log base x minus 3 minus 1. So I'm going to add the 1 over. So 1 equals log base 10 minus, then x minus 3. And again, this is the part I'd want by itself. Okay, so if I change that, that gives me 10 to the power of 1 equals x minus 3. And if I add 3 to both sides, x equals 13. So then the x-intercept is 13, 0. All right, let's see. Okay, I'll do this one right here. So you may use a calculator for these problems. So the population growth of zombies can be modeled by this equation, where P sub 0 is the population at 0, and P is the population of the time T. If there are currently 275 zombies, so that's my P sub 0, in Conroe, how long will it take for the zombie population to double? Well, if that doubles, that's 550, and so I just need to find out how much time. Okay, so again, you have to get that base and that exponent by themselves. So I'm going to divide that. That gives me 2 equals e to the power of 0.008 t. I can now change it. So ln 2, natural log of 2, equals 0.008 t. And if I divide, I'm going to find out what t equals. Okay, so you can use your calculator here. So if I use the calculator, I'm going to have natural log of 2, and I'm going to divide that by 0.008, and I get 86.64. So 84, and think round to the nearest tenth of a year, so 86.6. Oh, I wrote that wrong. So T equals 86.6 years. Okay. On this side here, let me see, we already did quite a few of these problems. I would say just remember, like on number 30, is you just kind of cancel these out, and then you just solve it like normal. So this one you'd have to equal 0 because of that, and then factor. On this one with the inverse, remember you want to switch it with the inverse. And then you're still, of course, always trying to get the log base something by itself. So it's subtract 12. That gives me x minus 12 equals log base 3 of y. And then I would just change it. The base stays the base and the other switch place. And so that is what your inverse would actually be. And remember, if it starts off with a log, the inverse has to be exponential. It has to be. Okay, that should be able to help you get through most of it at this point. That's about it.